misunderstanding. So I put all the detailed notes about that issue. And so maybe I can quickly go over those notes. Is that okay? So any other more topics we want to go over before this?
Go ahead.
Okay. Today Yang is not here. So this is the code. So basically during unmount device operation, so this is the function in the operator, like a executor, and we will have the unmount device operation. So reconciler already checking the desired actual state and decide, we have kind of like the mount information, like if any pod is mounting that volume, right? We put it in the actual state. And when reconciler trigger unmount device, that means in the actual state, there's no more pods are using this volume, so that we decide it's the time to unmount device, like the global mount pass. And but inside of this operation, we have this piece of code that is actually using the plugin, right? And to try to get the mount reference. So this will checking some mount path and to see if the given device mount path is actually right now still referenced using by some other by mount path. So we directly check that. And if there's no more reference, then we can safely go ahead to unmount device. Otherwise, we kind of stop here. And the problem raised for Yang's kind of investigation, because in some situation, this check will always fail that if for two unrelated, I think PV, right? But eventually they are using the same mount table or mount path. And this, even though it should be okay to unmount device, but because of that issue, so it will always stop here. So we want to see whether it is possible to remove this piece of code. And I was saying at that time, I add this part for during the reconstruction logic in the kubelet. The reason I added is because during reconstruction, right, reconciler at one hand it's trying to do some mount based on actual state and desired state, and the other hand they're doing reconstruction and put some mount information in the actual state, and it is possible there is a risk that even though you think it should unmount device, but actually there's still some mount reference using that. So to be safer, we want to add this part. And I have some kind of flows to, if you follow this, you might trigger that risk. However, I think reconstruction logic went through some changes quite a lot, and now I think it's I cannot say completely safe, but it should be quite much safer. Last time I think we talk about reconciler. There is reconcile, and also there is a sync basically doing reconstruction flow. And we thought they might run in parallel, but actually that code they are not running in parallel, so they are using the same thread. And during Kubernetes restarts, so the volume manager first will start reconcile call that function first. The reconcile right now, since it's Kubernetes restart, right, actual status has nothing. And what they do, reconcile can do is basically, if there's pods scheduled on that node, it will go through, scan that list of pod and add all the volume information into desired state. So that is the first time reconcile call. And then in the same thread, we will run the sync function call that is doing the reconstruction work. So what it does is scan the local directory, right, on that node. If there's mount pass, it will get all the information that could reconstruct the volume spec. If I think it's already in desired state, that's good. It will kind of match the desired state volume information and put in actual state. Otherwise, if the volume is not in desired state, but it should put in actual state. And after this reconstruction logic finish, and then reconciler will periodically continue to call reconcile, right, to compare actual state, desired state. And this reconstruction only run once after Kubernetes restarts. So
Wait,
that,
so the reconcile function is not it generally doesn't add anything to desired state. It only adds something to actual state, right?
oh, sorry, I said that wrong. So it, before reconcile can be called, we make sure there is a desired state populator that will do once, because we have a flag only after desired state populator finish at least once, we can start reconcile, I think. And reconcile, what it does is it check a desired state, right? At that time, actual state has nothing. So the reason we want that reconcile start first is so that it can go through the desired state, and then if possible, right, it will do the mount and put all the information into the actual state, so that actual state will has the correct volume information. And the reconstruction, we only if there's nothing in actual state, the desired state, it will put volume spec information into the actual state. Because reconstruction, as we know, is not absolutely completely correct information. Some information, especially for in-tree driver, it might have some kind of information we cannot fully reconstruct. So we just use the wrong information there. But as long as for unmount logic, it should be okay. It doesn't matter. But if it is need to be mount, then it will have some consequence. So that we want to run this reconcile once. I think that's the reason.
I guess the one. Sorry, Ben, go ahead.
Well, I'm trying to wrap my head around this. What we're basically saying is if the desired state is mounted, so we're trying to perform a mount, we're basically going to ignore anything that the reconstruction would have output, because we're just going to go ahead and try to do the mount. And then if it succeeds, say, yeah, it succeeded. And if it doesn't, say, no, it's not mounted yet. And so anything that the reconstruction would have output would have been ignored in that case. So don't even bother running it. Is that what I'm hearing?
Yes. So we don't want to put information that is not necessary, right?
But you're saying the reverse isn't true. Like if the desired state is it should not be mounted, then we do let the reconstruction try to figure out whether it's mounted so that we know if we have any work to do. Is that? That's how it works?
Can you say that again?
If the desired state is for it not to be mounted, then we let the reconstruction go take a look and see if it is in fact mounted, and we have to do work to get it unmounted. Is that's what I'm hearing?
Yes. So the reason we have reconstruction is mainly to address the problem that when Kubernetes restarts, and in the meantime, some pods got deleted. It might already deleted from API server, and but the mount has not yet cleaned up, so that since the in-memory cache information are all gone, right? The actual state is gone, so there's no kind of track of that volume mount anymore in the kubelet. So
what we're saying is reconstruction only matters on the teardown side, not the bring up side.
Yeah, right. So we don't want to interfere with bring up side. So that's why we want to let reconcile run once first, I think, and then reconstruction go ahead to check if that mount not in desired or actual state, they will reconstruct that, put it in actual state. And so reconciler controller will should trigger a mount.
Okay, all that makes sense to me. I wanted to get back to the original issue, which sort of made my ears perk up, because you said if it is the case you have two different PVs that somehow have a mount in common, like bad things happen. And I was like, wait a minute, we do that all the time. We have situations at NetApp where different PVs are actually hosted under the same NFS mount path, and so we would just recycle the NFS mount path for each PV that uses it. And you're saying there's some code somewhere that doesn't like that? I didn't understand that part of it.
Yeah, I think so. So you may like, I think we talk about issue Yang mentioned in some previous meeting. So if there are two CSI PV point to the same volume, we cannot start pods using those two PV on the same node. No, I think
this one, Ben, maybe this is, you don't have this use case. So this is for the SAFFS. So they basically says actually the same volume on the storage system, but that volume can have two volume IDs. So then they created two PVs, each with this a different volume handle pointing to the same one. So that's the problem. Do you have the same thing?
Yeah, we do that all over the place.
Really?
I mean,
then maybe you should look at this case. Do you have the same problem? Because there is a bug.
I haven't heard of this problem, so I'm wondering, is it something that we're just not triggering or not testing?
Maybe you didn't run into this. Yeah, because this one was just, we talked about this a few like last week.
I missed the meeting last week. Unfortunately, I had a conflict.
Yeah, take a look, because we don't have this, but I'm very interested. Yeah, is trying to.
Was the meeting recorded last week, so I can go back?
It is recorded.
Okay.
I'll see if it's check and see if it's posted. If not, then I'll see if somewhere in my local.
Okay, yeah, and if you can just send, I guess, the bug ID, or is it in the chat? No.
Yeah, the notes has this issue link, so it's October 27th. So there are two issues different, and I think the one related to the mount reference checking should be the second one here. That's why we are starting to investigate that piece of code, mount reference.
So in this case, I think I just wonder, Ben, basically you say in this case, it's the same mount point, but then there are two volumes. So I think that's the problem there.
So
well, in our case, it would be different directories, but the same NFS path. So it'll look like we're remounting the same NFS path.
It's the same problem, right?
It may not be the same problem. It's your case should, I think, probably okay. Yeah, it's a kind of unique situation.
No, I think the case with the same mount is still a problem. Like there could be cases where setup might break actually, because we check Yeah, like same like you're trying to use NFS with different subdirectories from two different parts, but the mount is same.
Something like that. Yeah.
Yeah.
Mm.
But you never run into problem, and in your at
Well,
least
I'm
never
I'm not
reported.
aware of any. I'm not
Okay.
aware of any problems, so I need to know what to go look for and what tests
Okay.
to run, because it could be that there is in fact a problem that's somehow gone undetected. So that's what I want to rule out.
Um,
You see a
so
jungle late.
Hey,
so
Yana's here.
I think,
yeah,
yeah, the problem is that if you use node stage with the same NFS server but different paths, then you will hit the problem. But we don't implement NFS, we don't implement node stage in NFS drivers
right.
usually.
Oh, Ben, right. So Ben, your driver, do you have the stage volume stage function implemented?
Yeah, because our driver is
You?
dual protocol,
Oh.
NFS and ISCSI, right?
Mhm.
So
Also that then you probably have the same issue then.
yeah,
Mhm.
it's entirely possible. So thank you for the links to these bugs. I'll look at them and ask some of my people on the team to go try to reproduce this and see if we have something similar. Because this is the kind of thing that like you might not notice, right? Like it's just it never gets unmounted, but like your Kubernetes cluster keeps working, right?
Yeah.
So
So yeah, then
I could see this going undetected.
right. So now for what I'm investigating is mainly focused on that piece of code to checking mount reference during the unmount device, whether it's very necessary, like possibly to remove that since it's cost like a if Yang want to fix something, right, that may block the kind of cost problem. And so what I'm saying is, I think the reason I added before to like to make sure there's no more reference. I think in the current reconstruction logic, it seems okay to remove that part because we make sure I add some like details. So maybe you can check whether it is logically right. But for that part, I don't think we need to worry much about. There's still some mounts.
Wait,
Like
is Kubernetes making the assumption that the path that gets passed into node stage volume will get turned into a mount? And like, does it, because we changed the CSI spec a year or so back to say that like you can put whatever you want into that directory. The staging path is just a path. You can put a bunch of JSON in there. You can put a bind mount. You can put symbolic links. You can, according to the CSI spec, it doesn't have to be a mount, right? It's just a space to put stuff that is required to stage the volume. And the only thing that has to be a mount is the path that gets passed to node publish volume. So are we making a presumption in kubelet that it is in fact a mount?
No. I think it works fine if it's not a mount, but we can have troubles if it is a mount.
Okay.
I think.
Because we might play a game where we like perform the mount, but on a subdirectory under that directory. So you give us the stage path, we create a subdirectory, we mount it there, and then maybe we avoid the problem because of that.
Maybe.
Okay, something to consider when looking at this code. Boy, I've had so many investigations these last 2 weeks. This is just yet another one. Things to go investigate.
Yeah. So you see how we do the mount reference check. I think it should be related to this code. So it finds all the mount reference to the path name. And so, yeah, there is some logic there, right? So I feel if possible, we do want to get rid of this. It's not that reliable. And the only thing is, on the other hand, right, we want to make sure when you perform unmount device, we do want to make sure there's no more like mounts that reference to that global mount path. And one thing when I check the code, I do see there might be tiny risks possible. I put it here. So later.
You're talking about the mount path, not the mount device, right? Like, it makes a huge difference because every driver is going to do different things with that path.
Right. So just from my understanding is what we want to make sure is during unmount device, and if the driver is using like mount path, right? So there should be no longer any mount path by mount using that global mount path.
How about a subdirectory of the global mount path?
Okay.
Would we notice that? Would we care?
I don't know. I need to check the maybe different driver, like they might use different way. For us, I mean the subpath of global mount point.
Right, the global mount point is what gets passed into node stage, right? And according to the CSI spec, it's just a directory, and the CSI plugin can do what it wants in that directory. That's what the CSI spec says, because we wanted to design it to be flexible enough that you didn't have to just mount something there. You could just put JSON there. Yeah.
So for our like a cloud like AWS or GCP, right? So we use that global mount path and then by mount to pod there into the pod directory mount path. So for us, it matters that we want to make sure. I don't know for other drivers. We want to make sure no more by mount exist before we issue like a unmount device for the global mount path. And what I'm saying here is seems in our reconciler logic, it might be still a little bit risk. So because what we do is before we can the moment we trigger unmount devices, we check actual state is our state. And the way we're checking now seems still not like a guarantee. So because when you check,
I'm still trying to understand. You're talking about unstage. How do you know if you need to unpublish a volume? Like if you had a pod running that with a published volume and kubelet crashed and kubelet comes back up and now it's supposed to go away, you're supposed to call node unpublish first, then node unstage. How do you know if it's published or not?
So reconciler do that part. Reconciler will first do unpublish because the actual state keep a record of for each volume. What are the pods are like using that volume? So it will keep a record of global mount path and also a record of each individual by mount, right?
And that state is stored outside the node, so the node can reboot and you can still retrieve the state.
No, that is not. It's through reconstruction.
Through reconstruction.
Right.
Can figure this out. All right.
Like it's partly stored outside, but like partly not, partly yes. So that's why the reconstruction logic is not perfect.
Yeah. So for CSI, it's much better, but for in-tray, we kind of just use some mount paths. We will go scan all the mount paths and figure out what information and reconstruct and then put it in actual state. So in some cases, it should be okay, right? The information is good enough to reconstruct the volumes back into the actual state.
I guess the only thing about removing that check is like, do we know for sure that when the check is run, is it possible that the desired state is not completely populated and the actual state is, and we are running the check and that's why we unmounted the volume?
So we do have a guarantee that we need to make sure all the sources are ready so that desired state should populate. But actually, I I think I encountered one issue before, because when you populate the desired state, you might temporarily hit some issue, right? You cannot get some information like due to API server, like or due to some unexpected issue, but it's temporary.
Right.
But since we only run it once, right, and we think you already populate the desired state, then we will go ahead to do the rest. So in that case, we do see like a problem, and then there is like a kind of a fix, because if the information is not populated in desired state, and we go ahead with reconstruction, and since reconstruction has some wrong information put into the actual state, it cause some information mismatch between actual and desired. But we do have a fix for that.
Yeah, we have that.
Mm,
We have
yeah,
that.
but here, what I don't know, it's kind of related, but maybe not. What we want to guarantee is, you know, um, when we trigger a mount device, right, on stage, it should be safe to do so, and whether it is safe or not. And
Yeah,
so,
I think that the from reconstruction's perspective, it is relatively safe because reconstruction doesn't run until the desired state is completely populated. There's a check that prevents. If reconstruction ran before desired state of the is populated, then we are in problem. But we don't have, we have a check to prevent that. The
yeah,
only thing is like the check itself, like the code in operation generator itself doesn't, and there's nothing else that could add to actual state of the world, right? Like if a volume was not, yeah, it should be okay. I mean, apart from the reconstruction logic, nothing
yeah,
else should add to actual state of the world at this point, right?
right. So I can rethink again, but from like last time, I consider reconstruction part. It seems okay. So everyone can like comment if you see some issues here. And the thing I noticed that might have slightly raised is during the normal operation. So the way we check, right? We first in the reconcile code, I think when there is a situation, some part deleted and the new part added almost at the same time, that uh, which using the same volume. So that means at the moment you probably into the when you check the actual state, and right, you think it's should be the time to unstage. However, at the same time, since another pod comes in using the same volume, and since you have an unstage, it's possible to try to like in the moment of trying to mount. So the thing we need to make sure is when mount device, right, we don't have new mounts are created at the same time. And so reconciler, the code is first to get all the volumes from actual state. Right? At that moment, there's no more like mount paths, like because all the paths deleted, which are using that volume. So it's the time for reconciler to think to trigger unstage. And then the logic is that they checking any pending operation and whether this volume is still in desired state or not. If it passed the checking, right, there's no more pending operation. It's there's no volume. This volume no longer in desired state. However, the risk I see is maybe when you check, the pending operation is just finished and update the actual state. Since we use we get the list from actual state first, right? But when you try to trigger the operation, at that moment, actual state might already updated. So the fix I'm thinking is just we at that moment we can check the actual state again. So it's safe because at this moment, no other the reconciler is like a single thread, right? Unless you trigger operation, but since you already checked, there's no pending operation, and next moment, there's no more operation should be triggered yet. So if you check the actual state again and just make sure it's not, during this period of time, it's not updated. So no months points were added into actual state. So it's,
how do we know that a new pending operation can't get added while we're looking at the actual state?
we check if there is any pending operation.
Right, but after that check is done, and we're checking the actual state, someone could add another pending operation, right?
No, there's no other pending operation because
then why not do the checks in the reverse order? Why not always check for pending operations before actual state?
yeah, it's also possible. It just it's a loop, right? We need to get the volume from actual state first. Otherwise, which pending operation you want to check? The pending operation is not, we are not checking all the pending operation. We are just checking any operation for this specific volume. And where you get the volume, you get that volume from actual state.
Okay. So this particular loop that is adding operations is a singleton thread.
Right.
And it serializes all of its work.
Yes. So that's like a small risk. It shouldn't, like, it's very, like, it's should not trigger that easily, right? It's very quick. It just to make sure we can add that extra check. So that's basically about this. I don't want to, oh, we already passed time, sorry. I have another meeting. That's about this, and I put some details here, and if you think any like missing, let me know. Very sorry, I have to jump right now.
Thank you, Jing.
Thank you.